Hello everyone, welcome back to the channel. In today's video, we're diving into one of the most commonly asked coding challenges in interviews: triangle and pyramid patterns in Python. These types of pattern problems are not just about printing shapes, but also about understanding loops, logic, and how to manipulate data on multiple levels. Whether you're a beginner trying to master loops or preparing for your next technical interview, understanding these patterns is crucial. So let's jump right in and tackle some practical examples. Definition: triangle and pyramid patterns are a popular type of coding problem often given in technical interviews to assess a programmer's understanding of loops and logic. The goal is to print a specific pattern, whether it's symbols, numbers, or characters in the shape of a triangle or pyramid. To achieve this, we typically use nested loops. The outer loop controls the number of rows, determining how many lines of the pattern you'll print. The inner loop manages the content of each row, which could involve printing characters like asterisks, numbers, or spaces to align the pattern correctly. For example, if we want to print a simple triangle pattern, the outer loop runs through each row and the inner loop prints the characters needed for that row. After each row is printed, we use print to move to the next line. This approach is simple yet effective for creating these kinds of patterns. By controlling the flow with loops, you can adjust the shape and size of the pattern, and it's a great way to practice your logic building skills in Python. Now that we've covered the basics of triangle and pyramid patterns and how they're built using loops, let's dive into some practical examples. We'll start with a simple triangle pattern, gradually move on to more complex designs so you can see how these patterns come together step by step. Let's get started. 1. Right angle triangle pattern. Question: write code to print a right angle triangle with n rows using asterisks. The right underscore angle underscore triangle function is a simple Python program that prints a right angle triangle pattern made of asterisks. The input n determines the height of the triangle, meaning how many rows it will have. For each row, the number of asterisks printed corresponds to the row number, forming the characteristic shape of a right angle triangle where each row gets progressively longer. Here's how the function works step by step, looping through rows. The for rows loop iterates from 1 to n plus 1, where n is the number of rows the triangle will have. The reason for using n plus 1 is that Python's range function excludes the upper limit, so to include the nth row, we must go up to n plus 1 printing asterisks. For each iteration of the loop, the current row number I is used to print I asterisks. The expression asterisk multiplied by creates a string of asterisks by multiplying the asterisk character by the current value of e. On the first iteration, it prints one asterisk. On the second iteration, it prints two asterisks, and so on until it prints asterisks in the last row new line for each row. After printing each row, Python automatically moves to the next line due to the default behavior of the print function, ensuring that each row of asterisk appears on a new line. The output of the right underscore angle underscore triangle 5 function creates a simple and clean right angle triangle made of asterisks. Starting with just one in the first row, each subsequent row adds one more, forming a gradually growing triangle that perfectly aligns on the left. By the time it reaches the fifth row, there are 5 asterisks, creating a balanced and neat triangle. It's an excellent way to visualize the structure, and the pattern is easy to follow with each row representing the next step in the triangle's growth. This simple yet effective use of loops demonstrates how you can control the number of characters printed in each row to form patterns, which is a common interview question in programming. 2. Inverted right angle triangle pattern. Question: write code to print an inverted right angle triangle 10 right-angle rows using asterisks. The inverted underscore triangle function is designed to print an inverted triangle pattern made of asterisks, where the input n determines the number of rows. In this pattern, the first row contains n asterisks, and each subsequent row contains one fewer asterisk than the previous row, eventually ending with a single asterisk in the last row. The function uses a for loop to handle this decreasing number of asterisks for each row. Here's how the function works step by step, looping in reverse. The for loop iterates from n down to 1 using range n, 0, -1. The range function here is used with three parameters. The first parameter n is the starting point, meaning the loop will begin by printing n asterisk in the first row. The second parameter 0 is the ending point, but it's excluded because range does not include the last value. So the loop will stop at 1. The third parameter -1 specifies that the loop should decrease by 1 on each iteration, effectively creating an inverted pattern printing asterisks. For each iteration of the loop, the current value of I determines how many asterisks will be printed. The expression asterisk multiplied by creates a string of asterisks by multiplying the asterisk's character by the current value of I. In the first iteration, it prints an asterisk. In the second iteration, it prints n means 1 asterisk and so on, until it prints 1 asterisk in the last row, new line for each row. After printing each row, Python automatically moves to the next line, ensuring that each row of asterisk appears on a new line. The output of the inverted underscore triangle 5 function creates a reverse right angle triangle made of asterisks. Starting with 5 asterisks in the first row, each subsequent row removes 1 asterisk, gradually shrinking the triangle down. The result is a clean, inverted triangle that perfectly aligns on the left, starting wide at the top and tapering down to a single asterisk in the last row. This pattern is a great visual for understanding reverse loops. This function provides a simple demonstration of how loops can be used to control both the number of iterations and the specific output for each iteration. In this case, the loop counts downwards, reducing the number of asterisks printed in each row, which results in the inverted triangle shape. 3. Pyramid pattern. Question: write code to print a pyramid with n rows using asterisks. The pyramid underscore pattern function is a simple yet effective way to print a pyramid of asterisks. The function takes an input n, which determines the number of rows in the pyramid. For each row, the function prints a combination of spaces and asterisks to create a pyramid shape, where the asterisks are sorted and the number of asterisks increases with each row. Here's how it works: step by step loop through rows. The for loop iterates from 1 to n each plus 1, where I represents the current row number. Each iteration of the loop corresponds to one row in the pyramid, printing spaces and asterisks. The key to creating the pyramid shape is in printing the right number of spaces and asterisks. For each row, the number of spaces before the asterisk is calculated as n minus s. This ensures that the pyramid is centered with fewer spaces. As the row number increases, the number of asterisks is determined by the formula 2 multiplied by I minus 1, which makes sure that the number of asterisks grows by 2 in each row. For example, the first row has 1 asterisk, the second row has 3, the third row has 5, and so on. Building the pyramid: in the first iteration, the function prints n minus 1 spaces and 1 asterisk, creating the top of the pyramid. In the second iteration, it prints n minus 2 spaces and 3 asterisks, and this pattern continues until the last row, where no spaces are printed and the maximum number of asterisks forms the base of the pyramid. The output of the pyramid underscore pattern 5 function creates a symmetrical pyramid made of asterisks. Starting with 1 asterisk in the top row, each subsequent row adds 2 more asterisks, forming a balanced pyramid that expands outward. The pyramid is centered by adding spaces before the asterisks, making sure that each row is aligned. The result is a visually appealing pattern that starts narrow at the top and widens as it descends, perfectly centered. This approach ensures that the pyramid is neatly centered and grows symmetrically, making the code both efficient and easy to understand. It's a great example of using loops to manage spacing and content in a pattern. 4. Inverted pyramid pattern. Question: write code to print an inverted pyramid with n rows using asterisk. The inverted underscore pyramid underscore pattern function is designed to print an inverted pyramid of asterisks, where the input n determines the number of rows in the pyramid. The pattern starts with the maximum number of asterisks in the first row and reduces the number of asterisks as it moves down, forming the inverted pyramid shape. Here's how it works step by step. Loop through rows in reverse, therefore loop runs from n down to 1. This means that the first row will have the maximum number of asterisks and each subsequent row will have fewer asterisks. The loop decreases by 1 on each iteration, ensuring that the number of rows reduces progressively. Printing spaces and asterisks. For each row, the number of spaces printed before the asterisk is determined by n minus I. This formula helps align the pyramid by adding more spaces as the number of asterisks decreases. So the pattern remains centered. The number of asterisks printed in each row is calculated by the formula 2 multiplied by I means C1, which starts with the maximum asterisk in the first row and decreases by 2 in each subsequent row. For example, if n equal to 5, the first row has 9 asterisks, the second row has 7, and so on until the last row has one asterisk aligning the pattern. The spaces before the asterisk ensure that the pyramid remains visually centered even as the number of asterisks decreases. The output of the inverted underscore pyramid underscore pattern 5 function creates an inverted pyramid made of asterisks. It starts with the maximum width in the first row with 9 asterisks and gradually decreases by 2 asterisks per row. The inverted pyramid is centered by adding spaces before the asterisk, ensuring that the pattern remains visually balanced as it shrinks. This produces a neat and symmetrical pyramid that tapers down to a single asterisk in the final row. This approach makes use of nested logic where spaces and asterisks are printed in proportion to the current row number. The number of spaces increases as the number of asterisks decreases, forming the inverted pyramid shape. This is a great way to practice understanding loops and how to manipulate printed output based on patterns. 5. Diamond pattern. Question: write code to print a diamond pattern using asterisks. The diamond underscore pattern function is designed to print the symmetrical diamond shaped pipe and of asterisks. The diamond consists of two parts: the upper part, which is essentially a pyramid, and the lower part, which is an inverted pyramid. The input n determines the number of rows in the upper part of the diamond, while the lower part is one row shorter to maintain symmetry. Here's how the function works step by step. Upper part of the diamond, the first loop runs from 1 to n. For each iteration, the number of asterisks increases by 2, starting from 1 asterisk in the first row to center the asterisks and give the diamond its shape. Spaces are printed before the asterisks. The number of spaces calculated by n minus I, which decreases as the row number increases, ensuring the pattern stays centered. For example, when n equal to 5. The first row has 4 spaces and 1 asterisk, the second row has 3 spaces and 3 asterisks, and so on, forming the top half of the diamond. Lower part of the diamond after the upper part is printed, the second loop starts at n minus 1 and runs down to 1. This loop mirrors the upper part, decreasing the number of asterisks by 2 in each row. The number of spaces increases as the rows go down, keeping the pattern centered. The lower part of the diamond starts with n minus 1 asterisk and ends with 1 asterisk, creating a smooth transition from the top to the bottom of the diamond. The output of the diamond underscore pattern 5 function creates a symmetrical diamond shape made of asterisks. The diamond is formed by two parts: the upper half a pyramid and the lower half an inverted pyramid. The upper part starts with 1 asterisk at the top and increases by 2 asterisks per row, while the lower part starts with the widest row and decreases by 2 asterisks per row. The use of spaces before the asterisk ensures that the diamond remains centered. The upper part creates the ascending pyramid and the lower part creates the descending inverted pyramid. This approach of using nested loops and controlling the number of spaces and asterisks helps form the desired diamond shape, making it a great example of how you can manipulate loops to create patterns in Python. 6. Half pyramid with numbers. Question: write code to print a half pyramid with numbers where each row contains numbers in increasing order. The half underscore pyramid underscore numbers function prints a half pyramid of numbers where the input n determines how many rows the pyramid will have. For each row, it prints numbers starting from 1 and going up to the row number. The numbers in each row increase as the row number increases, forming a pyramid shape. Here's how the function works step by step. Outer loop for rows. The outer loop runs from 1 to n, where I represents the current row number. For each row, the function will print numbers starting from 1 and ending at the current row number. I inner loop for printing numbers for each row. The inner loop starts from 1 and goes up to I. This loop prints the numbers on the same line. For example, in the first row, it prints just 1. In the second row, it prints 1, 2, and so on until the last row where it prints numbers from 1 to n controlling output. The end equal in the print function prevents Python from moving to the next line after each number, so all numbers for a given row are printed on the same line. Once the inner loop finishes printing numbers for a row, the print function moves to the next line, ensuring that the next row starts on a new line. The output of the half underscore pyramid underscore numbers 5 function creates a half pyramid of numbers. Starting with the number 1 in the first row, each subsequent row adds an additional number, building a pyramid where the numbers grow from 1 at the top to 5 in the last row. The function prints the numbers on the same line for each row, and once a row is complete, it moves to the next line. This simple function demonstrates how you can use nested loops to create number patterns, and it's a great way to understand how loops work together to control both the row and the content within each row. 7. Pascal's triangle. Question: write code to print Pascal's triangle with n rows. The Pascal's underscore triangle function is designed to print Pascal's triangle where each row contains numbers that are binomial coefficients. The triangle starts with 1 at the top, and each subsequent number in a row is the sum of the two numbers directly above it. The function uses two loops. The outer loop controls the number of rows, and the inner loop calculates and prints the values for each row. Here's how the function works. Outer loop for rows. The outer loop runs from 0 to n1, where I represents the current row number. For each row, the loop first prints spaces to center the triangle. The number of spaces is n minus I, which decreases as the row number increases, ensuring that the triangle stays centered, starting each row with 1. Each row in Pascal's triangle starts with the number 1, so the variable num is initialized to 1 at the start of each row inner loop for calculating numbers. The inner loop runs from 0 to I, meaning it prints 1 numbers in the current row. The first number in the row is always 1, and the subsequent numbers are calculated using the formula num equal to num multiplied by I minus j divided by j plus 1. This formula derives each number in the row from the previous one using the binomial coefficient printing the row. After the numbers for a row are printed, the print function moves to the next line, preparing for the next row. The inner loop continues for each row, gradually building Pascal's triangle. The output of the Pascal's underscore triangle 5 function generates Pascal's triangle, where each row contains numbers that are binomial coefficients. The triangle starts with 1 at the top, and each subsequent number in a row is computed based on the numbers above it. This pattern is widely used in mathematics to represent binomial expansions and is an interesting visual pattern to implement using loops. Great job, everyone. I hope these triangle and pyramid pattern examples helped you better understand how loops work in Python and how to think through logic problems during interviews. Remember, pattern problems can vary a lot in interviews, but the key is always in how you approach breaking them down. If you found this video helpful, don't forget to like, share, and subscribe for more Python interview prep and coding tutorials. See you in the next video.